Well, hi, and welcome to my shop this morning. I'm going to be starting on this radio, and with some luck I'll be finishing it all in one day. So now, if you're watching my videos as a subscriber, and you know I've been working on some other projects, a very large shortwave radio, that radio is off to the side here, just behind me, waiting now for the dial glass to come and some more parts to come. And I also have another project I haven't forgotten about, and that's a big amplifier for a Seaberg jukebox, which is also waiting for some tubes to come. And the good news on that is the 4 hard-to-get tubes for that amplifier have turned into easy-to-get brand new tubes from Russia. So a tube manufacturer in Russia has started making replacements for exactly the tube, and they're not expensive. So that'll be back in here before too long also, once the tubes show up. So in the meantime, I thought, why not take a run at a simple radio here, and that's how I'll pass my time while I'm waiting for parts to come. So this is a Northern Electric radio. I've done a number of these exact radios. This is the first one I've done that's in a wooden cabinet, though. I've never seen one in a wooden cabinet before. And the word is, this is my personal radio. I own this guy. Most of the things you see in my shop I do not own. Other people's radios. But this one is mine. So, let's see. It's just held on with 2 screws. Let's see what's in store here. There it is. Oh, a big sheet of asbestos sitting beneath the radio. Oh, a little bit of information here. Made in Belleville, Ontario. That's kind of interesting. A 35Z5 50L6. And then the classic 12 SA7, 12 SK7, 12 SQ7. Licensed by the Canadian Radio Patents, limited, guaranteed, made in Canada. Made in Ontario. Made a couple hundred miles from here. Okay. And I'm pretty sure the radio is just going to come right out. That's why I'm looking carefully, because usually when I'm pretty sure of things, I'm just trying to see how much is going to come out. It's possible this whole piece here is coming with the radio. Take off these dirty knobs. Now this is a 5-tube radio. I counted the 5 tubes. 5-tube radio, no power transformer in here. So this is your classic shock you to death from the chassis radio. Notice how long and deep these are. And notice at the front there's no metal knob sticking out. That's because they're dangerous. They don't want them sticking out. In case a kid pulls the knob off, he'd have to stick his finger in there to make contact. So it's certainly bolted in at the bottom. Flip this right on its face. There's 15 written here, and there's a 15 written on the back here too. 15. It's probably the price, $15. It's not the price I paid. So I got this radio by buying an entire collection from someone. I have 2 more of these radios. Not in the wooden cabinets though. In a plastic cabinet. So I'm taking this radio out because even if it works perfectly, which it may, I want to look underneath and see what kind of parts are in it. And I also want to check the tuning of it. I can, even if it's working great, check the alignment of the radio. Now the thing about buying somebody else's collection even if they're a bad radio collector, even if they really don't know what they're doing exactly, and they're kind of just buying what kind of comes in front of them, it's still a curated collection. Somebody made some decisions about what they wanted to buy, and so if you're lucky, you buy somebody's collection of radios, you get a lot of good radios all at once, which is what I hope happened. Because there were 15 radios I bought. I think I mentioned this quite a while, but a year ago I bought all these radios. I bought this collection because the price was good, and also I had run out of commercial work back then. I had nobody else's radio to work on, and my own radios, you know, they're all in good shape. So it was last winter, so I ended up working on my shop stuff. Again, if you're a subscriber, you probably remember me doing that and getting to some crazy sessions with vacuum tubes. That, by the way, was extremely helpful for me to learning some basic things. This should lift right out now. Okay, let's lift it right out. It's hanging on there. Here it comes. There we go. Now, see some curious stuff in here already. Let me just put this here for a second. We'll take a look inside the cabinet. Let's spin this around. Put this back up here. Well, the asbestos is, you see some asbestos material here, loose material. There's a large pile of it in here. And it looks like it's been chewed off or ground off of this edge here. Chewed off by a mouse or something like that. It's probably not terribly healthy for the mouse to be chewing on asbestos. There's a blob of solder here. So this probably fell in the radio when someone was working on it, and then they put the radio in, they turned it back over, and the little blob dropped out. I thought there were two of them I saw in here. Now, these, sometimes there's almost nothing holding these sheets in. I see a staple, otherwise they're just whacked in with a couple of staples. Sometimes there's nails that are hard to see. So my practice with this is I tend to leave them unless they're in bad shape and they're already starting to fry, which is the word for coming apart, like it is. You know, they serve a purpose in the radio here, but on an individual radio basis, having this in here doesn't make that much difference. If you have 40,000 of these radios out there in the world, then having a sheet of asbestos in every one of them is probably going to save somebody's house with 40,000 radios. But with one radio, the odds are very, very low that this would ever be helpful. It's a very, very cheap material, so the manufacturers threw it in there pretty straightforward. And this is obviously a wooden cabinet. And it might have even been a sales thing, where somebody might say, hey, how come, you know, I heard so-and-so's house burned down because their radio shorted out. I'm sure that happened. What are you doing about this? Don't worry, sir, we have a nice sheet of asbestos in there. If the fire doesn't kill you, the asbestos will. What should I do then? So my options are take this outside, knock everything out of it. Use a vacuum everything out. Pop the asbestos sheet off and get rid of it once and for all. Now, one of the problems in the earlier days, and I don't think it would qualify for this is a post-World War II radio. The earlier back you go, the better English you use. So you go back in time, electric systems got, like the kind producing power for your house, got more and more dangerous all the way back until the very, very first electric systems were put in people's homes. They're very, very dangerous stuff. Lots of fires happening in that. So, and it's still true today, I'm sure. I can't even remember what my point was with that. So, oh yeah, that's right. So the protection, literally the fuse box or circuit breakers in people's homes got better and better and more reliable, and people got more reliable, and electricians got more reliable. Everything got more reliable. The chance of a radio having a short in it that can start a fire because it goes down, down, down. So, okay, so adding all those things together, what should I do about this piece of asbestos? Now, some people like to cover it. Guys like me doing this kind of stuff, or people doing this kind of stuff, like to cover it with something. You could do that. I think what I'm going to do is I'm going to take it out. I'm going to go outside my house. I'm going to pop this out. I don't think it's held in very well at all. No, it's not held in well at all. Just these. So I'm going to pop these out right here. You see how it's coming up. I'll take this outside. Now, how do you dispose of asbestos? I don't know about where you live, but where I live, and I think it's probably typical of most, this amount of asbestos is not considered a hazard in itself. Then the way you handle it is stick it into bags, plastic bags, a bag inside a bag, like a double bag it, throw it in the regular garbage, say goodbye to it. Okay, I gotta go out and do that. Actually, you know what, I can set this aside, I'll do it later. I don't have to do it right now, do it later. Now the next question is any of that asbestos dust here on this radio, and I'm going to be exposed to it. So the bottom edge here is going to have asbestos fibers on it. Now again, is this enough to worry about? In my honest opinion, no. But it's just going to take a moment. Aha! Very interesting. We're starting to see what's underneath here. Stay up there, would you? Just stay up there. So I just want to paper towel that edge off. Asbestos fibers aren't like other fibers. They are rigid. They can't be bent. They're pieces of stone, right? So they're crystal fibers. But they're not like other fibers like cloth and that. They cannot be bent. I guess these hard, unforgiving fibers go in your lungs and get stuck in there and somehow through some mechanism initiate cancer. Yuck. Nobody wants that. Now what are we going to do here? So clearly somebody's worked on this radio because you can see the two replacement capacitors for this one up here. It's a 40-40-40-20. 40-40-40-20. So, different guys would do different things, or different repair people do different things. So here's two 50, these are probably 50s. Where's the third 50? Third 50 and the 20. So there's a good chance they're still using this. Good chance of that. Oh, I hear cats crying outside. Hello, listen. I think there's two of them out there. Okay, cat break. Let me take a cat break briefly. Come on. Meow. Welcome. Yes. You want to help out? We got another radio up here. Come on. Come on, jump up on the bench here. There's no power or anything. Where are you? Come on. Come on up here. Actually, you know what? You can be more entertaining than the radio itself. Okay. So getting back to the radio. Now, all the paper condensers are still in here. Condensers. Wow. A sudden journey back in time. And even though you can't see it now because it's all... The screen's gone black. What's happened? So I'm looking at the high wattage resistors here. Now, having the cat in here maybe not the best idea. Okay, but don't get in front of the camera now. So high wattage, high wattage, high wattage. Thought I saw another one. So do they look damaged, overheated, or does any of this look bad? No, it doesn't actually. And I'm going to take a wild guess that all these paper capacitors are still pretty good. So this is the hum killer method that's been used. Nicely done. They're in here pretty solid. He's used a very stiff piece of wire here to kind of hold them a little bit. Stiff wire here too. Short lengths, so these won't flop around. Now, the other capacitor, did he disconnect it? Because sometimes what guys do is they just parallel in more. That's a very common thing to do. And it looks to me like all the wires are still connected to the original capacitor. So that's what he's done. He's jumped in there, he's paralleled in a couple of these, done a nice job on it, and that was good enough. Was it? Was it good enough? Was it really good enough? Let's find out. So I would imagine probably this radio was never aligned. It's probably just what it is, except, you know, when it was originally made in the factory. And on that note, that's a little overdone. How come this is kind of kooky here? It's just a regular light bulb. Wow, look. Man alive, what are they conveying to that light? Just ordinary. Well, that's a good question. What are they conveying to this light? The light, this is a 6-volt light. Where does it get its 6 volts from? Since there's no transformer, it's not coming from a 6-volt winding on a transformer. Where does it come from? It comes from a carefully constructed center tapped heater in the rectifier tube. Carefully constructed and center tapped so that you can draw off one half of the filament enough current to power the light and maintain the operation of the radio. That's where the 6 volts comes from. Roughly 6 volts. Okay. Lots of curious thoughts about that too. Well, people have. Check for tuning. Yep. Volume on off. Okay, switch off. Now we'll put the power on here. I use a restriction, just one light bulb. Are you ready, cat? Now don't stick your tongue on this radio or anywhere else in here. No tonguing of the equipment, cat. We'll watch the lights. It's not turned on yet. No reason to watch the lights, Jim. Ready? Here we go. The light. The light. Okay, it did exactly what it should. All good. Volume's right down. What do you hear, Shadow? Don't get your nose in there now. Generally speaking, there's nothing too dangerous up here, I don't think. Okay, volume up. It's still warming up. Oh, so something funny going on there. Quite a strong hum. A really strong hum in it. Tuning. That's an unacceptable hum. So I bought this is part of a curated radio collection, and I was told all the radios work, but I know better than to believe that. Some people would say this radio works. Hey, where's the antenna? Oh, what am I talking about? It's right here. Where's the antenna? Receiving nothing, making hum. Okay, wow. Well, it's not nearly as... That's certainly not good. Not good. out. Well, what should we do here, Kat? What do you think? So the hum issue. Let's just take a look here and see. Good. Well, basically this is about the easiest and simple thing you can do to a radio to try to bring it back to life, and that's throw in a little extra capacitance into the power supply filter to try to cut back the hum. Didn't seem to work. Oh, my other cat's calling. Cat break. So my cats call each other. Okay, so I think they either want to go outside or to the garage. I'm going to go let them in the garage. Guys, this way. No, this way. Come on. Come on. Uh-oh. Okay, no interest in going in the garage. I'm not too interested in going in there myself. They want to go outside, so I'm probably only going to last another 15 minutes here before they will drive me crazy. So one thing I'm not going to do is jump in and start changing all these paper capacitors. I suspect they're all okay at this point. That's my suspicion there. To get rid of the hum, it's all about the power supply filter or perhaps the rectifier tube. So one thing we can do, take a close look at how these were put in. Were they really put in against the proper sections of the main filter capacitor? Probably were. If that's the case, then I'll try to free off or remove the original capacitor from the circuit, which right away makes this whole thing much more difficult. As you can see in this radio, the terminals on the capacitor have a lot of stuff connected to them. This is a cheap way to build a radio, and I mean that's the objective here, is to build a radio for as little money as possible. That means there's no terminals to reconnect all these wires. If I lift them off, what do I do? Stick them all together in the air? I mean that's one alternative. So I got to think about that a little bit. Here they come. The tag team. I'm just looking very carefully at it now, at all the parts. There's that other high wattage one back there. But by the way, all the high wattage resistors look great. The radio doesn't appear to have a lot of mileage on it, as best I can tell. Speaker's in great shape. It's well worth working on. Cabinets of a sort that you could easily refinish and make it look like new again. A lot of radio cabinets, it's pretty tough to do that. I gotta think. I gotta make. It's a big decision about what to do about this. It's an hour or two of effort, one way or t'other. Yeah, maybe I will take a little break, go outside with my cats for a bit. So the question is, did this guy connect the new filter capacitors correctly? And I'm sure the answer is going to be yes. Well, let's just see if we can figure that out. So here they are here, and clearly the negative is coming up here and going to this terminal, which is on the CAN part of the capacitor here. So there's a terminal here, there's another CAN, if you like, outside CAN terminal here too, just by the way. And now the other four are all actual capacitor terminals. You notice the color of the wires? Red here, red here, red here, orange here. So what's going on with this orange one? And first of all, let's back up just a little bit. So this capacitor has 4 sections in it. I think it was a 40, 40, 40, 20, I think. I didn't bother looking again, but I think it's 40, 40, 40, 20. So the 20, the smaller capacitance, is almost certainly the bypass capacitance for the cathode bias resistor on the output tube. So if we follow this orange wire, it probably goes up. It disappeared. Where did it go? So it connects right back here where you can't quite see it to this tube, and this tube is the output tube. So I think we know without any doubt this is the bypass capacitor here. Now if we look at the remaining 3 terminals, you see 2 of them are connected with this high wattage resistor. One of them has nothing else on it but this red wire. And this wire appear to be headed in the same way. And they are. They are headed over to this tube. One is connecting here. You notice that's connected to the positive of this capacitor. And the other one is connected, it's a little hard to see it here. There it is right there. It's connected here. And you can see there's a wire going to this capacitor. So that's the 2 capacitors here are actually connected to these 2 terminals. Not much left now. Now on one side of this resistor is bound to be, well, I better not say bound to be. This has 3 sections, so I won't say that. On one side of this is going to be the connections into the radio. So you can see there's just a red wire on this side, but on this side there's all these red wires heading out, one going to each tube. So this is the B plus coming out into the radio. Okay, so we see that this last capacitor here is not boosted by any additional capacitance. He's put 2 in, boosting this and this, but he hasn't boosted this, unless I've missed something. Did I miss something? So if we look around, we follow any one of these, we're looking for another capacitor stuck in there, but I'm sure we would have seen it already. So one option I have to try to reduce the hum is simply boost this one with another 50. Put another 50 on here. And also, because this is a single wire, if I choose to, I could disconnect this wire and test the capacitor fairly easily. Disconnecting all these wires, no, not worth doing. Can this capacitor, if it's weak, cause the hum? This is the orange one here. No, I don't think you get a hum from this. You're going to get a hum from insufficient filtering. So he's boosted 2 of 3. Why don't we boost the 3rd one? We'll just do it temporarily. I'll temporarily put another 50 capacitor on there, and we'll see what happens in terms of the hum. I can arrange it so I can switch the capacitor in and out, and we can hear it come and go. So I just need a couple of clip leads to do this. Want to put one on the ground here, on the chassis. White to the chassis. I'm going to get a capacitor right away. So we want a. So this is a 350 volt capacitor. That's a little much, but that's okay. No harm in that. A 50. This is the grounded end, so we want to go on the negative end. Do it like this. Okay, then the positive end, which we're not going to quite connect up. I'm gonna pick. I can pick it off anywhere these red wires run. So I'm gonna attach over here where I can do it very securely with a clip lead. And what we'll do is we'll start the radio up like this, and then I can separate this off, and we'll see if the hum comes and goes. When I do that, I'll leave the radio tipped on its side here. Maybe just make that a wee bit better. Switch is on, volume is down. Keep your eye on the dim lights over here. There we go. Capacitor connected. Now the more and more capacitance you put in one of these radios, depending upon where you're putting it, can put more and more, to call it, instant load, I guess, onto the rectifier. It's probably a limit to how much you can put in here before you cause a problem with the rectifier tube during startup. Don't know whether that's completely true. Okay, let's hear it. Certainly got a bit of a problem here. Seemed to me the hum came a little late in the game. Definitely there. What's up with that control? So we're going to try to clean this before we go any further, because with the dirty volume control, when the slider lifts off, if it's not making electrical contact down on the surface inside the control there, if it lifts off, it becomes high impedance, and next thing you know, you're hearing hums and stuff. Quite confusing about where exactly they're coming from. So let's clean them up. Oh, son of a gun! I have to run. We'll be back in just 1 second. Okay, let's get gravity working for me so I can spray a little bit of this WD-40. Like this. Come back. I like to do this with the radio on. It's not on in this case though, because you can hear it coming clean. Okay, let's try it again here. Capacitor's still in. Doesn't seem to make any difference. Plug her back in here. Okay, we're on again. Takes a long time to warm up. So, what is happening here? So I can hear the volume going up and down with this thing. Hum is going up and down. What happens up at the very top here? Is that the radio? Yeah, it is. What is going on here? Oh, okay. This is not good. So this is sort of suggesting a cold solder joint in there somewhere. Is it my capacitor connection? It could easily be the capacitor connection here. Let's just be a little careful how you pick this up now. I'm going to separate this. Any difference in the hum? No. So the hum can be coming out of the rectifier tube. So I wanted to move the additional capacitor to another place just to double check. So I'm going to turn the power off while I do this. Oh, that's the ground. I don't want to take that off. I want to move this one from to the other side of the resistor there. So we can get in here and get right on that resistor lead. Wow, that's not very good. Get some follow the wire. Okay, well, I'm adding the capacitor to the capacitor here. Well, let's try it. Let's try it. And it's really a fat chance that these are defective. It's really, really, really unlikely. So I'm just piling in the capacitance here. Okay, just making sure. Okay, okay, made sure. There we go. Another pop. Another pop. Well, the hum is there. Let's disconnect, see what happens. That made more hum. Okay, so with that observation now, I started wondering if we shouldn't remove the connections to this original capacitor. So what I'm going to do is I'm going to take off the easy connection, and we're going to test that one section of this big capacitor to help us judge about the rest of it. I think that's probably the best way to go. Power off. Plug out. Let's give this guy a little bit of time to bleed down those voltages. So on a radio like this, you can expect maybe 150, 160 volts for B+. It's backed up by quite a bit of capacitance, of course. You don't want to get a shock off that. That's for sure. But it's half what you find in a bigger radio. 160 volts. Oh my gosh, another visit from cats. I did go outside with my cats for a while. But that was then and this is now. So I just want to nip off or desolder right in here. Soldering iron's warming up. Let's go see it. Who's here? Aha! Yes, what? You out? Yeah, I see you looking. So, I don't know, did you see my cat just now? When I asked him what is it, he kind of turned his head to his left quickly, and that's his communication. What do you want? Turning his head to the left, he's saying, I want to go this way. That's how I understand my cat. And then I close the door. I understand my cat. Close. So I'm going to get a little bit of a spark here. Let me just ground this guy temporarily here. I can kaboomy. No sparks. No sparks flying. So I've chosen, obviously, to desolder this rather than rip it, rather than cut it off. Rip it off. Yeah, I'm going to rip it off. I may not be able to get this off, though. Once this is off, there's probably little reason to ever connect it back. Yeah, that's not going to come off. There's no reason to connect it back. Cut it. Cut it off. Cut it off. Jim, come on. Use your brain. Oh, smokes, what did I cut there? Is there another wire? There wasn't, was there? No. Absolutely. Really making sure there isn't another wire there. Okay, so this wire just out here now. We'll put on the capacitor checker. Fortunately, I have the leads ready. Okay, so negative to ground, positive side to the positive terminal. Now that capacitor on the top is covered in cardboard. It could have a metal can underneath the cardboard. I'm not sure. Metal cans way better than cardboard. If you find those yellow capacitors, you know, that are often installed down here, you have the leads coming out either end, and they're almost always yellow. Those things are crap. But the ones up on top, if they have a metal can on them, they're often good for a long time. It's all about moisture getting in them, I suppose. Okay, so this is an electrolytic capacitor, so I'll flip this to electrolytic. And we're going to start with putting 50 volts on it. Expectation is this will close and slowly open as the capacitor charges and get back to pretty much this position. If all is good. If all is good. Here we go. So we see it's getting right back to the original position. So in terms of leak, it's not serious. And you give it a little bit of time to discharge. When you release this control on this machine, it puts a short on the capacitor leads. So I'm just giving it a little bit of time here to bleed it right down. Then we'll measure the capacitance on it. It's supposed to be 40, right? So 40, where would 40? 40 would be in here, 0.1 to 50. So that's this scale ending in 50 right here. So I'd expect it to be 50, 10, 50. Oh, so 40 is right here. So we're going to expect this to come right here. Let's see what happens. There we go. Oh. So it's opening. It's not opening fully. And it's around 20 on here. Let us check this out. I'm going to take the brand new capacitor here. I'm going to hook it up. We'll see. We'll just compare it. So this is a 50, not a 40. I've got the short on it here. Just trying to make sure it's down to nothing. Positive. Okay, let me just, something funny happened on my computer here. Okay. So no need to test this for leakage. It's a brand new capacitor. It's all about its size. Let's see. So here you see right up close to 50, just about dead on. And see how much it opens wide. Now there's another adjustment here, power factor adjustment. So you're supposed to turn the power factor adjustment for maximum opening. Power factor here is basically 0. Now that's a measurement of the quality of the capacitor. We'll go back to the old one. Let's go back to the old one. I'll repeat that. So we'll try to measure the power factor. There's other terms used aside from power factor for this. Way. So again, we'll bring this to the, so it's barely opening now. We'll adjust the power factor. So you see where it maximizes up here, so you see the power factor is coming in at 20 what? I don't know. 20 what? I don't know what that is. 20%? I don't know. So, but a good capacitor is going to it's going to be wide open down here at 0 power factor. So what we're seeing here is unquantified indication that the capacitor is worn out. Now I can't imagine having it connected is causing a problem really. What it would be is just basically doing nothing, having that connected. Snip this. piece of wire off, so a little less likely to short. So we'll test it again, and we'll see what we get. We'll reconnect this up. This is positive here. And the negative. So the question would be now, if the test that I did on this one section of the capacitor, is it applicable to the other sections? Probably is. And just how bad did it come out? Not really bad. So the question is, less hum now. This gets a little tricky, of course. We're just relying on our memory here for hum comparison. And we got this right. Negative to the negative. Right. Positive, we're on the, I think is the first capacitor. On we go. Should plug in the radio. Plug her in. There we go. Takes a long time. Don't hear any hum yet. Don't hum. Let's turn it up. Voice came out of it. What's the matter with this volume control? That it has to go all the way up there to engage. It doesn't seem like dirt because it's not scratchy. It's nothing, and then it's everything. The hum is completely gone. Well, there's a lesson. That's quite a lesson. I really didn't think removing this wire was going to end any hum. My guess is you got to put a new volume control on this to get anywhere with it. Because there's just nothing happening here. There's not even a click or a pop in this area. And then suddenly, that's basically, you know what this is? This is getting all the way to the far end and contacting the terminal inside. That's what I imagine. I imagine there's a horseshoe-shaped sliding surface, and the slider's going around it, and at either end are the connections made to it, which are difficult to make, by the way. So it will look a little more like this. And I'm putting the slider all the way over and hitting this connection. And anywhere else, there's nothing. I just don't think it's going to come back, no matter how much I sit there and spin it around. So that's the story. The story is we need a new volume control with a switch on the back. Oh man. Okay, but kind of happy about the capacitor thing. That was a bit of a lesson for me. Oh, wait a minute, the lesson's not over. Wow, I really find it hard to believe that disconnecting that one wire from a 3-part capacitor was enough to eliminate the hum in here, but it did. Great. That's great, except for the volume control thing. That's really a drag. That's a big drag. I have more of these radios. Would I take one apart to put this one together? They also have an awful lot of volume controls. So I'm going to go through them and see if I got any with switches on the back. We'll see. Okay, so I did say I have a lot of volume controls. Here they are. Now most of these are for European radios. Very, very specific. So I'm going to go through this box, see if I can find a suitable volume control with a switch on the back and the right resistance. I'm not even sure the resistance that I'm using yet. Boy, oh boy, oh boy. Can you see that monster through there? Look at that. Wow. That has a switch on the back. But it may not be appropriate, so I will study this up and see what I can find in there. It turns out none of those controls are going to work in this case, so I've gone and grabbed this chassis here. This has been in a box in my garage. One of my customers handed me this when he picked up his radio and said, "Here you go, maybe this is of some use to you." And it hasn't been, of course, no use to me until just now. Maybe the on-off switch. So I ran out, dug it out of the box. I said, "Oh, there's no switch here. There's no switch here." While I'm looking at it, I notice, hey, what's with all these cut-off wires here? All around this open hole. Somebody beat me to it. Somebody got the switch. And that's why I've been handed this. It has no on-off switch. Okay, so this isn't going to work either. I think I have more tricks up my sleeve, though. Well, let's see. One alternative I have here is to just replace the volume control part here. Forsake the on-off switch entirely. Wire up the radio so it's on whenever it's plugged in, and then rely on plugging it in and unplugging it to turn it on and off. That's one approach. Pretty simple. Low risk. Another approach is to install a new on-off switch, most likely on the back of the radio. So you have to reach around and click it on, and then put in just a regular volume control here with no on-off. That's a slightly better option, except it involves a little bit of wiring. It involves wiring the 120 volts part of it, so a little bit of safety concern and stuff like that. And I think that's probably the best alternative, but the easiest for sure. It's the plug in and plug out deal. Oh my gosh, who's at my door now? Oh, you're inside. Okay. Out you go. Go on. Good cat. A little confused? Not quite sure what all that was about, but so I need to know the value of this control up here. We're going to be removing it for sure. Yeah, there's a chance I can fix this. Maybe there's a remote. A very remote chance, but we can certainly take this apart and find out what went on with it. I'm going to cut one wire off, just one, in the back here. No, I'm going to cut two wires off. Oh boy, they're the same colors. So before I go any further, I think I need to photograph that very carefully. Okay, now we're set to read the resistance of the variable resistor. Open. What do you think? Open circuit. Any surprise there? There's something. That's going up like it's charging a capacitor. going to go up over 2 million. These controls, you know, usually, well, let me say right there, no. Okay, let's go on the slider. And then the back one on the slider. 0. So that's off. Turn it up. This appears to be working. Let's take a closer look. It's kind of inconclusive test there. See, I've cut one lead off so that it's not so this test can't be interfered with. Let's put it that way. But I actually left a wire on there. Really? Over 2? I thought we were seeing something here before. And we got the clip lead question. I set when I discover a clip lead is no longer working right, I set it aside for, when I get 5 or 10 of them there, then I'll go through them and resolder them or whatever it is. Let's try this again. Yeah, it looks like I'm there. Doing the same thing. Heading for up over 2 million. Put this on the 20. So moving this control shouldn't really make a difference. I've still got more leads connected to it. Let me cut away the other one here. Could just get out the schematic diagram for this radio and read the value. Okay, so now the back, that terminal is completely free. Wasn't before. Go back. Repeat this. $500,000. As soon as I turn it up a bit, it's just gone open and it's charging a capacitor. Let's cut some more leads off. This will be tricky here. Tricky to put the new one in. I'm cutting the leads, it might come short. Cut them all off. All off. Okay, so there's nothing on the volume control anymore. Go on the outside of it. Really? Oh, what's going on there? Yeah, I think any way you spell this, it comes out to defect. Okay, off with the power connections. And, you know, this is a ruined switch. I'm going to ruin it further. I'm going to cut off the terminals on it. Maybe I shouldn't do that because just maybe it's repairable inside. What are the chances? Really low. Okay, so we'll leave the terminals on. Oh my gosh, there's 1, 2, 3, 4. No, there's 3 connections in here. Hope I took some good photos. Okay. Take them right out. Wasn't expecting to do this, but that's kind of par for the course when you're doing this work. All over me here. Okay, nothing can interfere now with this test. So we're reading the resistance of the skid surface. I don't know what to call it. Open circuit. Are we sure? No, we're not. We're using clip leads here. Okay, let's try without the clip leads. Let's short a clip lead and make sure. Oh yeah. There you go. Proof positive. Now we'll go on the slider here and see what happens, just for fun's sake. Fun, fun, fun. Here we go. Nothing happening. Ooh, what's that? My guess is the internal surface that the slider slides on has become disconnected from one of these terminals. Go on the other side. Maybe this time we'll see something. So that's 500,000. So this side's working fine. Problem is this terminal here. Should be able to generate a zero resistance by doing that. Oh, there's a zero. But I've made it onto the terminal. Now if I turn it, I'll cross the break inside here and suddenly it will go open circuit. And that's exactly what it sounded like when we were playing it. And there's no question that this is defective inside. Very often they have the value of these written right on them. Of course this one's broken now, but I can still get it by using the slider. So we're going to go on here, the good end. I'm so oiled up here. Go on the slider. And if I turn it for maximum resistance, wait a minute, what happened? This was working before. I got more bad clip leads. Oh my gosh. Yeah, don't work with greased up, oiled up hands here. Okay, we're just going to short that. Good. And put it here. Short. Get on there. Oh my gosh. Got it. Yeah, right. What? I must have turned this control right around or something in the middle of doing that. Let's go back on the other side. Yeah, I guess I did. I don't know. Okay, so 500,000. So 500,000 is what this is. 500,000, that's a fairly common value for these guys. I should have one. 500,000. I won't have one with a switch on the back though. Now we'll go through my old guys here. And of course they gotta kind of fit. They gotta kind of match the shaft length here. Ooh. Plus you really want a half moon shaft. Can I meet all those requirements? That's a lot. That's a lot. I have to change knobs. That's a 1000. That's the one out of the radio. Oh my gosh. Put a double in. just use one part of it. When you put one in with a long shaft, you can cut it shorter, but I can't make the D part, the D shape. Yeah, I suppose I could, you know, grind it off. Ooh boy. I gotta go look for proper control here. Well, I'm really having a hard time finding an alternative. So I have this one. This is 1.2 megohms, and this is half a megohm. That's really quite a difference. But, physically, it's just about right. Doesn't have the D-shaped shaft. Probably deal with that. As I said before, I think I should take this apart now. We'll look inside. Is it possible to repair these? Doubt it very, very much. So I'm just going to bend open these tabs. Basically, I'm not trying to cut them even though I'm using cutters. I just trying to get a grip on them. Generally speaking, these tabs cannot be bent up and down like this. You might get away with one cycle. Or maybe a couple of these will close back down if by somehow I can fix this thing. I'm not sure what's going to happen when I open this up. What's holding it? Not much. Let's get a good close look at this. We'll see what's up with it. See if we can see where the actual defect is in it. Just going to maximize the focus here. Now, which one is it that's broken? Good question. Okay, so I think it's this one, right where the slider is now. Certainly got lots of WD-40 in it, didn't I? So, the place where these will fail, maybe I've got it backwards here. Let me get a little pointer. They tend to fail right in here. Right across in here. So that side looks okay, but the other side, so maybe I do have this turned around. The other side looks broken to me. It's really hard to see in here, isn't it? Well, so I'm thinking there's a break right in here. The other side. Okay, let me get my meter out here. Just take a quick check again. I fiddled with it now. It may have remade its connection, but not in any kind of reliable way. So let me just check here. It's a little awkward with it. Like this now. across, still open. Okay, from this one to the middle, from the other one to the middle. There we are. So this is the good one, this is the bad one. Let's take a good look at the bad one. Why exactly is it bad? It didn't look bad. Why are you a bad one? It's very hard to light this any kind of decent way. So another possibility here is the rivet is no longer connecting. So they rivet the terminal onto the black material. That's a pretty good look at it. Okay, let's so is it the rivet? I think I can get my ohmmeter leads in there. Let's see what happens. You can watch what I'm doing and I'll just tell you what's happening. So yeah, watch what I'm doing here. Not sure about this. So what I'm doing is I'm trying to contact the trying to keep this in view of the camera actually. Let's just use the slider up here. And I'm going to run the other lead on the material. Okay, so I'm reading 400K. 400. Oh, something just happened there. 400. 420. 450. Open circuit. And on the rivet it's open circuit. Okay, I'm getting 400. Open circuit right there. It looks like it's right across here and you can't even see it. Okay, so I got 425. 450. Kind of jumped up to 500 and back. Oh, open circuit. So it's right across here somewhere. Let's try down this way. So it's open, open, open. Nope. Oh, whoop, open again. There. 410. Can't really see it, but there's some kind of break right in here. Completely invisible. I've certainly seen these where you can definitely see a crack go right across it. Well, can't make out any problem with it, but you can see how they've made the center of the slider connection, that piece of copper wire going up and disappearing underneath the slider. So up under there has to be a sliding contact arrangement. You can kind of see it up in there. You know, that can give you trouble too, I suppose. But my experience has been it's a failure of these connections right in here. You know, if the control is a little bit loose on the radio, and so when people move the control, like move the shaft, especially when they're turning it off, you know, this is an off switch, right? So you're applying. Oh, well, it's an off, but it's not ever coming on again. But the on-off thing, you put a little pressure on it, and if the control is at all loose in the radio, then it's going to work. It's going to work these a little bit. It's going to get worked. So you can see how the wires would transfer mechanical forces right up through the termination and right into the slider material there, whatever that is. That's my theory on that. It's worn out. That's the bottom line. Okay, so no hope for fixing this. No hope. There's hopeless. So we're going to try this, or I'm going to stop and look for another alternative. This guy is, oh, this isn't the one. It says 85K on it. Hey, where'd the one go I was going to use? This one. M5150. Never been used. And it does measure. Let me just measure it one more time. And I will go away and think about this for a while. Fair bit of work to get this in place, and then, you know, if it's not going to work. Oop. .25. So half a meg versus something, you know, getting on towards 3 times its size. What would be the importance? It's a voltage divider. So even with a different resistance in there, you'll still pick off the same percentage of the signal with the slider. You're picking it off through more resistance. I don't know. Maybe an experiment. Maybe the fact is it's not that critical. In fact, I don't know. Lunchtime is coming. Okay, well, hello again. It's the next day actually, and I've just finished shaping this control here to match the original one. We'll take a closer look at it and see how I did this. I just cut it the same length and then dremelled away the material here. Looks good. Oh, look at that. Fantastic. Okay, well, we don't know if this is fantastic. I won't know until I stick it in, because it's quite a different value. But the only way to find out is to actually install this thing all the way back into the radio and hook the whole thing up. Find out then if it works. So, okay, that's what I'm going to get busy doing. I'm going to install that guy back there. Okay, so I'm still working on putting in the control here. I'm partway through it now. And I'm about to reconnect this resistor, and I thought, well, I'll just test it. So it's supposed to be 2.2 megohms. It's 2.7 megohms. It's coming up a little short anyway, so I'm going to replace it. But otherwise, I'm not replacing these capacitors. That might not be the smartest move, but that's what I'm doing. Still working at it. Okay, I think we reached the point now where we can test this radio out and see if I've made some kind of egregious error in here. Everything looks good. Okay, I did damage this terminal a little bit when I was messing around with that control, so let's just hope. I gave it a quick test, it seemed okay, but maybe not. Okay. Now, this radio is now an on all the time radio. As soon as I plug it in, it's on. Of course, I don't have power in my outlet, so in fact, plugging it in here isn't going to snap it on right away. Well, check for escape routes. Cats in the area. Will the knob go on? Yep. Now, no on off. Okay. Volume down. I hope it's down. Downwards. Okay, now dim light's really important this time around. So we're still on just one light. That's hardly a restriction, in fact. It's a restriction if there's a serious short circuit, which, you know, I've done a lot of work in here. I could easily have made a mistake. So I hit the power. If this light comes on full blast, then we know something went wrong. Smoke comes out of the radio, we also know something went wrong. Here we go. Oh, warming up just right. That's a good sign. Now, this is an experiment to see if this incorrect volume control is going to do the job anyway. I hope it will. Just let it keep warming up. The volume is turned right down. Shouldn't matter when the volume's turned right down, shouldn't matter what kind of control you got in there. Okay, here we go. The moment. Uh-oh. Well, there's something coming out of it. Let's turn it up.
Other teachers and high school teachers. And I didn't talk today. Many teachers, grade school, telling me that she was hearing that teachers in high school.
Okay, well, I think we're in business. What was that? Ooh, what's going on there? I got this whole thing up in my hand. That's a little nerve-wracking while I'm doing that. Let's try it again. So that sounded like a tuning issue of some sort. Is it the loose capacitor?
Online, so even though I
Or directional antenna, eh?
I'm not going to get a grade that says good. So you're waiting for calculus. So what does that mean? What do you mean by I'm not going to get a grade that's that good and good because you're taking the class online? So online, basically, it's lectures that are done by teachers. I'm going over a PowerPoint. I'm going over a and that's on a discussion board.
Nice. No hum. Beautiful.
24 hours later.
Excellent. Okay, so the next stage here with this guy will be an alignment, and we're done. Wonderful. Okay, that's going to come a little later. I think we're good for right now.